Hello everyone. I welcome you all in the next lecture of 12th class NCERT Mathematics. In this video lecture, we will discuss question number 9 of exercise 5.2 of topic differentiability. So, before the 9 question, we discussed already 8 questions of exercise 5.2. You can see from my playlist. It is available there in a calculus playlist. Okay, there you can find also the continued topic completely, in which I solved each and every question. Okay. Now in this question you can see that prove that the function f given by f of x equals to mod of x minus 1, x belongs to R, f is not differentiable at x equal to 1. Here you can see the function is defined as mod of x minus 1 for all x belongs to R, and that means it is a modulus function. Before we discussed the 1 to 8 question. In those we have a composition function, or we have a rational type functions we have actually. Okay, so in all those functions we have a method. The method is, you have first method we learned that our product rule, then we quotient rule, then we have a chain rule. But out of all these three, none of the method is applied for this question. Okay, so for the differentiability, as we need to prove that the function is not differentiable, we need to go by the actual definition. Okay, so here none of the method is applicable here. There is no method applicable here out from all of these. We need to go by the LHD and RHD, the left hand derivative and right hand derivative at x equal to 1. We need to evaluate. How we can evaluate, you can see here. First of all, we need to redefine the function f of x is equals to the, how we can redefine it. If your x minus 1 is greater than equal to 0, then you will get x minus 1, and if your x minus 1 is less than 0, then you will get minus of x minus 1 you have. Again, if we redefine it, okay, then what we'll get, here you can see if x is greater than equal to 1, then you will get x minus 1 simply, and minus x, wait, I will write it in a proper manner, minus x plus 1 if x is less than 1. This is your f of x. Okay, now we need to evaluate at 1, because we need to prove that the function is not differentiable at x equal to 1. So LHD we need to find. How we can find LHD? Limit x tends to 1 negative f of x minus f of 1 upon x minus 1. Now here you have limit h tends to 0 f of 1 minus h minus f of 1 upon 1 minus h minus 1. Here you can see that your LHD will come limit h tends to 0 f of 1 minus h, we will leave it here as it is. Okay, wait for a second, wait, we will put the value also, no? Okay, here we will put the value. How we can find the value? You can see here, that suppose this is your 1, so as h is your positive quantity, so 1 minus h will be your, wait, I will write minus h will be your less than 0. Hence if it is less than 0, then what you can write, 1 minus h will be less than 1. It means guarantee 1 minus h will be lie on the left side of the 1. If it is left side of the 1, it means the value f of 1 minus h we can find by the second piece. And how we can find? Minus of 1 minus h I will put here, 1 minus h I will put it here, and plus 1 is there. Okay, now we'll discuss our, wait, I'll write minus f of 1. F of 1 we can find by our first branch, that is 0, first piece, and hence here you can see 1 cancel, minus h will be here. Now limit h tends to 0, what we have here, minus 1 plus h plus 1 upon minus h we have here. Okay, if we, because minus 1 cancel, and h was, we had 1 minus 1. Okay, so the LHD for this function, for this we have minus 1. Now we need to find the RHD. And how we can find the RHD? Wait for a second. Okay, yeah, here we can find the RHD. How we can find your RHD will be limit x tends to 1 positive f of x minus f of 1 upon x minus 1. Now what you have, limit h tends to 0, wait, limit h tends to 0, here f of 1 plus h minus f of 1 upon 1 plus h minus 1 we have. Okay, now here you can see that as h is your positive quantity, so 1 plus h will be bigger than 1. It means, suppose here 1 is there, so the 1 plus h will be lie on the right side of the 1. So here is the right side of the 1, then we need to find by the second piece. Okay, the value have a 1 plus h, so limit h tends to 0, 1 plus h minus 1 will be here, minus f of 1 value is 0 again, and here 1 plus h will be cancelled as get only h, and here 1 1 cancel, again we are getting, here we will get 1. Okay, this is your second equation, and this is your first equation. Okay, so from first and second equation we have LHD at 1 is not equal to RHD at 1, implies that f is not differentiable at 1. Okay, hence proved, hence proved. Okay, I hope you understood. I will write in a proper manner, is not differentiable at 1. So I hope you understood this complete question. What we says here, I will give you quick recap of this question. Here the function is given as mod of x minus 1, so we can redefine this function as like that. Here we redefine this one. Okay, and after redefine, as the function is not in the form of the quotient chain or a composition or a chain rule, we can't apply here, we can't apply product rule, we can't apply direct differentiation. So what we can do here, that we need to go by the definition. Okay, and as also they are proving that we need to prove that the function is not differentiable at x equal to 1. So just we need to do at 1 we need to find LHD, at 1 we need to find the RHD and check are these equal. So we need to apply our definition here, simple, and we get the value that LHD is minus 1, RHD is 1, and both are not equal and the function is not differentiable. I hope you understood this question. Thank you for watching. If you have any doubt, then you can ask me in comment. I will rectify your query there. Okay, still if you have a query, then I will make separate video for your query. Thank you for watching.